In this video, I'm going to review with you a few basic terms that we use when we talk about statistics. In particular, I'm going to talk about terms that relate to error and uncertainty. First, though, I wanted to explain a little bit about why I'm making you do some of this statistical stuff. Basically, nowadays, understanding really basic statistics and being literate in data is really essential to being a good citizen. So many political arguments are made using statistics and data, you also need to be able to do this effectively. And so for this class, I'm not going to ask you to do any statistics, you don't need to produce anything, but you do need to understand the terms and you need to be able to read related graphs and tables. Why? Essentially this.
And if you look at death,
Start to go up
here's
again.
one. Well, right here, United States is lowest in numerous categories. We're lower than the world.
Lower than
We're
the
lower
world.
than
What is that?
Europe.
In what?
Look.
In what?
Take a look. Right here. Here's case death.
Oh, you're doing death as a proportion of cases. I'm talking about death as a proportion of population. That's where the US is really bad.
Well,
Much worse than South Korea, Germany, etc.
you can't do that.
I'm not saying whether an argument about a particular statistic is right or wrong, but what I do want you to be able to do is to sound really smart when you're making that argument. To start off with, I wanted to review a couple of terms that you probably learned in high school or earlier, and that's mean, median, and mode. Just as a reminder, the mean is what we normally think of as the average. It's the sum of all data divided by the number of data points. Median is the number that's about halfway through. There are the same number before and after it. And mode is the most common number in a group of data. So the good news here is that almost always in comparative politics and political science generally, we're just interested in the mean. We're almost always talking about average as you normally think about it. But when we get to talking about uncertainty and error, things get a lot more complicated. There are a bunch of different terms that we use when talking about uncertainty around those means, around those averages. One is variance, standard error, confidence interval, p-value, or just margin of error. I'm not giving you specific definitions of all these terms because it's not that important, they get a little complicated. What's important is that all of these terms refer to uncertainty around an individual data point, around a mean. The easiest way to think about this is in terms of a poll. Here we have a recent poll about who you're going to vote for president in the upcoming election. You can see here there are two averages, the percentage of people who said they were going to vote for Biden and the percentage of people who said they were going to vote for Trump. Any decent poll, though, is also going to give you a margin of error, but it's usually in teeny tiny points. You can see down here the margin of error is plus or minus 3.7 percentage points. I'm going to round up to 4. What that means is that on average, 52% of people said they would vote for Biden, but they can't 100% be sure about that. Yeah, the number could be as high as 56% or as low as 48%. That same error is around the average for Trump. So Trump's voting percentage could be as high as 46%. And while the poll makes it look like there's a 10 percentage point difference between Biden and Trump, it could in fact be as small as 2 percentage points, which doesn't look quite as impressive. The confidence interval and the margin of error are really useful to work with because you can just add and subtract them from the mean. These two terms, confidence interval and margin of error, mean exactly the same thing, and again, it's just this plus or minus. These other terms, variance, standard error, and p-value, have much more complicated definitions. And while it's great if you can get a confidence interval around a number that's easy to understand, sometimes all you're going to get is a standard error. I'm not interested in having you try to calculate then, okay, what's the plus and minus on this number for governance? All I want you to know at this time, and all I want you to look for at this time, is does an author or does a data set provide you any estimate of standard error, uncertainty, in whatever form. Stronger data sets are going to at least provide you this information. Weaker data sets are not necessarily going to give that information to you. You can also think about confidence intervals and margins of errors graphically. Sometimes they're represented as a shaded bar around a line. This line here represents the average of all of the dots. And the gray bar, that's the up and down, the plus and minus, the confidence interval around that average straight line. Sometimes you'll see confidence intervals and margins of error represented as lines. These are also relatively easy to understand. The top point on the line represents the highest possible value for this blue average dot. The bottom point on the line represents the lowest possible value, again, around this single point. And what this line here is telling you, kind of like the red line here, this is an average of all the numbers. And so what you look for is, okay, does this cross the line or does it not cross the line? Values that cross the line, here represented in green, could actually represent a correct average for the overall data set. The red line here, if it does not cross the average, if the margin of error does not cross the average, then you're looking at a very weak piece of data. To give you a concrete example from a data set we'll be using on Friday, this is a graphical representation of one of the World Bank governance indicators, one for voice and accountability in Afghanistan from 1996 to 2018. And here you can see, again, the dark blue line represents the average of all this data for each year. And the gray bars represent the margin of error around that line. Now, this would be nice if they actually gave you the numbers for margin of error. You could do a little bit more with it. But you can also just sometimes eyeball things off graphs. And again, what you're looking for here is the difference between the highest value of one point and the lowest value of another point. Kind of like we looked at on the Biden-Trump poll, what's the lowest possible percentage approval for Biden compared to the highest possible percentage value for Trump? And we use this when we want to compare things over time. So if you wanted to say, oh, hey, you know what, based on this blue line, it kind of looks like between 2002 and 2007, voice and accountability, whatever that is, increased in Afghanistan. That's great. But if you look at the margins of error, there's not really any discernible difference. The highest possible value in 2002 is not greater than the lowest possible value down here in 2006 or 7, whenever this is. By contrast, if you look at the comparison between 1996 and 2018 or 2017, there actually is a difference. Overall, there's an increase in trend in the blue line, and the highest possible value for 1995 or 1996 is in fact lower than the lowest possible value for 2017 or 2018. You can see that there's a gap or a difference here. This is the kind of information that I want to see you getting out of graphs, just being able to understand what you're looking at and draw some basic conclusions. The second thing that I want to talk to, again going back to polling, is the other piece of information that they gave you here in the teeny tiny little box, and that's sample. They say the sample size is 957 likely voters. Samples and populations are all things that we use to refer to scope. What exactly are we studying? Who exactly are we looking at if we're doing a survey? In this case, the population is every member of the group that you're studying. When we're talking about surveys about American politics, we're almost always looking at the voting age American population. In comparative politics, though, a population might be all countries in the world in the year 2000. A sample is a smaller group that you're going to collect data on, and it's meant to represent the entire population. CBS and YouGov talked to about 950 people and are using the information they gathered from those 950 people to draw conclusions about all the American voters. In comparative politics, though, oftentimes this sample is the population itself. We're actually going to gather data on every single country in the world or every single country in Africa, every single case of civil war, or every single political party in a country. In cases like that, you'll often read research that just refers to N, literally just N, as in the number of cases. This is an example from an article you're going to read next week about state development in Latin America. It is an article that includes statistical analysis, and the table that gives the results, again, just has this line and just has this reference to N. And N here means the number of cases. In this case, it must be the number of interstate and civil wars in Latin America over the number of years that they actually studied. So what I'm interested in you getting out of a table like this, which looks super complicated to start with, is to start being able to break it down into its elements. N, again, the number of cases is all I want to get you to get right now. We'll talk a little bit more about some other important information, but we've touched on it already. The SE here stands for standard error, and these P's down here represent p-values. Those are all estimates of error around these coefficients, which we're going to talk about more next week. So just to sum up, there are lots of different sources of uncertainty. A big one is that your sample does not represent your population. This is a big source of error in polling. Another potential source of uncertainty and error is measurement bias in the underlying data. That's why I've had having you watch all these videos about conceptualization and operationalization and what does it mean when we look at indicators and big concepts. It's about measurement bias. There are lots of other sources of uncertainty, but let's just focus on these for right now. Again, the key point right now is that you want to understand and look at whether it is at all possible to measure the uncertainty in what you're talking about. If you're dealing with numbers, the answer is yes. If you're dealing with words and events, maybe not so much. But if it's possible to measure the uncertainty around whatever it is that you're working with, does the author of an article or a data set give you that number? If it's possible, you want to see it. Because if the level of uncertainty is really high, the data that they've given you is almost meaningless. And that's it for now.